So this problem is number 30 on page 348 in the Oscillations and Waves unit. This problem is dealing with sound waves in an open tube. So the problem reads, determine the length of an open organ pipe that emits middle C 262 Hertz when the temperature is 21 degrees Celsius. What are the wavelength and frequency of the fundamental standing wave in the tube? What are the wavelength and frequency in the traveling sound wave produced in the outside air? So I would start with writing down the given quantities. So the fundamental frequency is equal to 262 Hertz. Always write down the units. Temperature is room temperature, so 21 degrees Celsius. And so knowing these quantities, I would start with the formula for velocity of the sound in air. So the formula is velocity is equal to 331 meters per second plus 0.6 meters per second multiplied by t, and where t is temperature in degrees Celsius. So what we are solving for here is velocity because we do not know that. And so just plug that into your calculator, where you plug 21 in for t. And if you plug that in, so 331 plus 0.6 times 21 is equal to 343.6. So velocity is equal to 343.6. Don't have to worry about sig figs yet because that is not what we are, in the conclusion is what we are looking for. And so now we know the velocity of the wave and we know the fundamental frequency as given to us, 262 Hertz. And so the formula relating velocity, frequency, and wavelength for sound is velocity is equal to frequency times wavelength. And so plugging the velocity and frequency in, you get 343.6 is equal to frequency 262 multiplied by the wavelength, which is the unknown that we are trying to solve for here. And if you plug all those values in, you plug it into your calculator, I am getting wavelength is equal to 1.31 meters. And so then, since it's an open tube, that means that the fundamental frequency is going to go fundamental frequency F2, F3, and the formula for open tubes relating length and wavelength is, the length of the tube and wavelength is L is equal to N divided by 2 wavelength, where N is like the number of frequency, the frequency number. And so L is equal to N divided by 2 times wavelength. And hold on, let me. Okay, so that is the image for a fundamental frequency of wavelength in an open tube. And so since it's a fundamental frequency, the formula for fundamental frequency is L is equal to N, or N is equal to 1. So 1 divided by 2 multiplied by wavelength. Oh, let me move that up here. Alright, you know what? We're just gonna not even worry about it. Sorry about that, guys. And so, since we know the wavelength after we just found that, so to find the length of the open tube, which is what it's asking for in part A, we can just plug in all our known values. So L is equal to 1 divided by 2. So 1/2 times the wavelength, and the wavelength, as we found, is 1.131. And so plugging that into your calculator, you get L is equal to 0.656. And now you always have to be wary of sig figs. So since it's 1.31, that's 3 sig figs. So you can have 3 sig figs in your answer. And so 0.656, sorry guys, supposed to be a point, meters, as the length is obviously in meters, units. And so that's your answer to part A. All right. So now part B, it asks, what are the wavelength and frequency of the fundamental standing waves in the tube? So in looking for part A, we actually found the wavelength and the frequency of the fundamental standing wave in the tube. So we can just write, so part B is just what we found earlier. So wavelength is equal to 1.31 meters, and frequency is given to us is 262 hertz. All right. Part C, it asks, what are wavelength and frequency in the traveling sound wave produced in the outside air? So if it's produced in the outside air as to versus the open tube that it was produced in originally, it is pretty much the same. It acts as the same way because it is an open tube, so it's just the same qualities as the open air it'll have. So the frequency and the wavelength does not change. So the frequency is still going to be 262 hertz, and the wavelength is still going to be 1.31 meters. So nothing changes as an open tube acts the same as an open air. Okay, so that is problem number 30 on page 348. Hopefully that answered all your questions. And so, signing off. Hey, Ray.